Herzlich willkommen zu unserem heutigen Webinar live aus dem Energiestudio in Berlin. Mein Name ist Charlie Grüneberg und ich leite die Kommunikation bei die Gas- und Wasserstoffwirtschaft. In unserer heutigen Veranstaltung wollen wir uns unter dem Titel Turn Up with Ammonia genauer mit der Rolle des Ammoniakmoleküls und für eine künftige Wasserstoffwirtschaft befassen. Wir haben uns in den vergangenen Monaten immer wieder mit dem Thema Wasserstoff auseinandergesetzt und eine Frage, auf die wir dabei immer wieder kamen, war die, wie Wasserstoff aus anderen Erdteilen nach Deutschland transportiert werden kann. Ein Medium, das dabei immer wieder genannt wird, ist Ammoniak, NH3, ein stechend riechendes, in Wasser gut lösliches, farbloses Gas aus einem Stickstoff und 3 Wasserstoffatomen. Wir werden das Webinar heute in Englisch durchführen, da wir internationale Referenten zu Gast haben, die ich Ihnen nun vorstellen darf. And so a warm welcome to Stephen Jackson, CEO of Ammonia Europe. Ammonia Europe is the voice of the European ammonia industry and its value chain with the mission to advance the decarbonization of the industry. Stephen brings experience from previous roles at Hydrogen Europe, several consulting companies and the European Commission. Stephen, can you hear us? Great, wonderful, okay. Our second guest is Ignacio Fernandez Santiago, CTO of Fertighy. Fertighy was founded by several companies, among them Siemens Financial Services and Heineken, with the aim of pioneering the low-carbon transition of the European fertilizers industry. Fertighy aims to produce affordable and low-carbon fertilizers for European farmers, and Ignacio has years of project management and engineering experience in large industrial and infrastructure projects in the fertilizers, energy, and oil and gas sector. Ignacio, you can also hear us?
Yes, I can hear you. Good afternoon.
Great, wonderful. And our third guest is Luis Viga, President Brazil, Fortescue Future Industries. Fortescue Metals is a global leader in the iron ore industry with its home base in Western Australia. But in Brazil, the company develops large green hydrogen investments. Luis has also large and recognized experience in different operations of the oil and gas and of the renewables industry. Luis, you can hear us?
Yes, Charlie.
Also. Wonderful, great. Okay. The event will be recorded and published on our YouTube channel afterwards. We will also send you the speakers' presentations and the link to the recording later. And if you have any questions, feel free to use the hand lifting function or chat. So I would start with you, Stephen. As CEO of Ammonia Europe, Stephen will explain to us how ammonia can be established as an energy source in Europe, which political conditions must be met, and what developments are emerging for the coming years. Stephen, the floor is yours.
Hello, good afternoon, everyone. Thank you very much for the invitation. I will be giving a presentation about Ammonia Europe. We are a newly established business association in Brussels. Our whole purpose is to bring together and to represent the ammonia value chain in Europe and defend the ammonia industry towards European policymakers. One of the reasons being that in Brussels interest groups, up until now, the ammonia value chain has not been represented by one body, but by multiple different bodies. Whether it be considered as a chemical or as a fertilizer or as a hydrogen derivative. But actually, the ammonia value chain has a value chain of its own. And the existing value chain is, as we know, essentially linked to the fertilizer industry, but also chemicals and refrigerants. And that is the conventional business that we need to decarbonize. And I'm sure Ignacio will talk more about that specific part. But we are also focusing as part of our activities at Ammonia Europe in developing the new value chains for ammonia. And when I mean the new value chains of ammonia, that is for maritime, so direct use of ammonia as a marine fuel, for deep sea shipping, and then as well using ammonia for energy storage and potentially production, depending on which member state we are talking about. And then a bit more broadly, talking about ammonia as a hydrogen carrier. As you know, it is easier to transport ammonia than it is to actually transport hydrogen. So most likely, most of hydrogen trade globally will actually be done in the form of ammonia. So bearing what I said, obviously what we see is our vision by 2050 is that we envisage a decarbonized ammonia industry and the uptake of clean ammonia across a wide variety of sectors in Europe's climate neutral and resilient economy. So that was to what I was saying before. Basically, our sole vision is to expand basically the ammonia value chain into new downstream sectors. As part of our activities, so we promote the role of ammonia as a precursor of multiple value chains, as I mentioned. We advocate towards EU institutions, but also member states within different geographies in Europe. Fundamentally, we need to bring together the broader ammonia value chain together. So that is on the industry side. We also act as a trusted partner and a reference point for ammonia safety and technology. I like to say that when it comes to ammonia, safety is our business card. So it's a topic that we take very seriously and where we are putting quite a bit of effort. And last but not least, we need to continue investing in research, development, and innovation into ammonia technologies, whether it be for ammonia synthesis or for ammonia cracking, ammonia bunkering, and ammonia propulsion. Our founding members are here. You can see which of them they are. They are all the major ammonia producers in Europe. We represent, as part of our membership, all the biggest producers. We account for above 30% of all hydrogen produced and consumed in Europe. That is over 32 production plants, over 30 terminals for imports and exports of ammonia. And just to give you an idea, the European production accounts for about 10% of global ammonia production. And with all our founding members, we've been obviously handling ammonia for over 100 years in a safe and trusted manner. And now we're ready to expand into new value chains. As part of our activities, we produce knowledge on safety and technologies. We work on policy influence, so that is inserting ourselves into current debates, whether it be the Green Deal implementation, but I think now increasingly linked to the Clean Industrial Deal, which was published a couple of days ago. And that's basically bringing together the necessity to decarbonize, but with the economic reality on the ground. And so we are very strongly advocating on those specific files. I mean, I'm sure we can further discuss afterwards which kind of conditions are required for the ramp up of the ammonia value chain in Europe. Also importantly, we're working on certification as part of our activities. We as Ammonia Europe are colorblind in terms of production pathways, but what is very important is to ensure trust and accountability. And so therefore we have published our own certification scheme as part of our activities. And then we organize a number of networking events and communication stunts as well. Just a few words on the certification scheme I mentioned. It was published Beginning of the year, we basically look to certify 3 different production pathway, Refunobio compliant, biomethane, and CCS ammonia. The production can occur wherever in the world, but the end use has to be in the European Union. We use, in terms of chain of custody, essentially a mass balance, but with an optional and restricted book and claim within the European single market and within the same company. And so importantly, at the end of the certification process, we issue ammonia certificates to make sure that the end users actually get the molecule that they paid for. So that's just Ammonia Europe in a few words. In terms of activities, now just the membership sectors represented, and we've now opened up our membership to companies beyond production. So looking to attract logistics companies, whether they be ports, terminaling, and companies involved in the transportation and pipelines for ammonia. As well as technology providers, developers, engineers, ammonia cracking, and so forth, as well as the new and traditional end uses for ammonia. So that was ammonia in a nutshell. Obviously, I invite you to ask any questions as part of this webinar or afterwards via email. Thank you very much for your attention.
Thank you, Stephen, for this short overview of the important work of Ammonia Europe. Next, we welcome once again Ignacio Fernandez Santiago. He is Chief Technology Officer of Fertighy. Fertighy was founded in 2023 to decarbonize the European fertilizer industry. The company relies on green ammonia and renewable energy to produce low CO2 fertilizers for European farmers. And Ignacio will now give us insights into Fertighy's first large-scale production plant in France that uses green ammonia. Welcome, Ignacio, once again.
Thank you, and good afternoon, everybody. I will share my screen with the presentation that will follow. So just to start, a few words about who is Fertighy and who is behind this project. Fertighy is a company that was created in 2023, as you mentioned, and it was created with the intention of developing, building, and operating low-carbon fertilizers plants in Europe. This means fertilizers plants in which the hydrogen required to produce ammonia is not produced using natural gas, but using electrolysis to produce hydrogen from the water. The company is based in Spain. We are based in Madrid, and the first project that we are developing, and that we'll explain later, is being developed in France. Something that I would like to highlight with this slide is that Fertighy, in this objective of producing low carbon fertilizers, provides 2 relevant values. One thing is that the final product and the target of takers have been always part of the business plans since the beginning, since the creation of the company. It was always clear that the objective was to produce nitrogen fertilizers like CAN, calcium ammonium nitrate. And the other important value is that to get this objective, we have actors in our shareholders that can provide value across the value chain to get to the final product. Because we have Rick Energy from the energy starting point of view. Then we have 2 actors that will help us in the industrial part, which are Maire and Siemens. And then we have 2 shareholders, which in addition of being shareholders, they will also have the possibility to contribute to the distribution through in vivo and to the final use of the fertilizers through Heineken. And finally, and not the less important, we have InnoEnergy, that was the builder of this company, together with the IGAC that belongs to InnoEnergy, and that is the one that put the cap table for all the shareholders that we got later. Another thing very important is, okay, which are the problems identified and the solutions or the opportunities that Fertighy can provide in this production of low carbon fertilizers. First thing is the decarbonization, of course. This is clear. Fertilizers account for a big portion of the global greenhouse gas emissions, around 2% in the world. And these CO2 emissions, in addition of the environmental impact, they also have an economical impact because of the CO2 prices increasing if this is produced, if the fertilizers are produced in Europe. And the other thing is the CBAM if the fertilizers are produced out of Europe. So for this decarbonization problem, what we can provide is a 90% reduction in the greenhouse gas emissions. The other point, and also very important, is the dependency on imports. When we talk about Europe, most of the fertilizers that we consume, around 2/3, are imported, are produced out of Europe, if we take the global of the fertilizers used in Europe. So this creates a dependency on third countries, that especially when there are geopolitical issues like Russia-Ukraine, that was an example. This creates dependency on Europe, and this creates at the end uncertainty and lack of security in the food value chain. So this is another objective, to avoid the dependency of third countries in everything related with food production. And last and not less important is the price volatility. The usual production of fertilizers is linked to the production with natural gas. This means that it is linked to the prices of natural gas that have peaks, and especially when there are crises like wars or the other events in the world, that at the end, when the natural gas price increases, the ammonia price increases, the fertilizers use is reduced because the farmers cannot afford the high price of fertilizers. And at the end, when there is less fertilizer, there is less production of food, and we enter again in the problem of food security. So these are the three problems and the three potential solutions that Ferti is trying to provide. So just now going a little bit in the details of the project, we have in this slide, the only thing we show is that for the production of the the fertilizers, basically what we will replace is the production of hydrogen. Instead of producing gray hydrogen using SMR from natural gas, we will replace it with electrolysis using low carbon electricity. The rest of the process, with some differences that we will explain later, but the rest of the process can be equivalent. The difference is in the production of the hydrogen that is used to produce the ammonia. Here in this, well, this is similar to the other scheme, but this one is more detailed to explain about the project that Ferti is developing currently in France. As I said, the hydrogen that we will produce will be electrolytic hydrogen. So starting with the energy production, we will not have, as part of our project, we will not have renewable assets. The energy will be sourced from the grid, taking advantage of the low carbon electricity available in France, thanks to the combination of clean energies, form of nuclear and renewables. And we will combine this electricity from the grid with PPAs, renewable PPAs. So taking this electricity, we produce hydrogen, 200 megawatts of electrolysis capacity to produce hydrogen. As a next step in a process that is well known, combining the hydrogen with the nitrogen from there, we go to the ammonia production. And then we go to the fertilizers part, which is the production of nitric acid from the ammonia. The production of nitric acid is not more than an oxidation of the ammonia. And then combining this nitric acid with another stream of ammonia, we go to ammonium nitrate. And then finally, this ammonium nitrate is combined with dolomite, which is a mineral mainly with calcium and magnesium, that gives two benefits to the final product, which is the CIN27. And these two benefits, one of them is that it reduces the hazards, it reduces the potential of explosion of ammonium nitrate. And the other advantage that the dolomite provides is that the calcium and magnesium are two components that are needed for the crops. The production of this plant with 200 megawatts electrolysis will be 500,000 tons per year of CIN, calcium ammonium nitrate 27. And for doing all this project, we have selected the technology partners that you can see here in the screen. We have selected the licensors for all the processes, for the ammonia, nitric acid, ammonium nitrate. These licensors, which are Stambi Carbon and Incro, have been selected since the early stages of the project, since the feasibility study. And now, before entering into the feed engineering, we try to select the electrolyzers provided. And this is finally just to conclude very quickly about the details of the project. Some information about the project that we are doing in France. As I mentioned, the project is in France. It is in the region of Hauts-de-France, in the department of La Somme, inside the Hauts-de-France. And there are several reasons why this location was selected, which provides some advantages for the type of product we want to develop. First of all, as I mentioned before, being in France gives us the possibility to have access to low carbon electricity available in the grid mix. By doing this, we avoid the problems of intermittency in the production, we reduce the storage of hydrogen or ammonia, and this is good things when we try to develop a large-scale project like this. Other thing is the consumption of fertilizers. This region of Hauts-de-France, and in particular the department of La Somme, is one of the most important agriculture areas in Europe. This means one of the areas in which there is more consumption of fertilizers. So this will allow us to have the production close to the final users. The location of Hauts-de-France, in addition of this big consumption of fertilizer locally, this will allow us to have access to 2 canals. Our plant is located close to one canal and will be located one to another canal that is now under construction. So this will allow us to have access to the ports of Dunkirk or Le Havre, or to other areas in Benelux using the river waterways, which is an optimum solution for the distribution of the fertilizers. Then, last point, but not less important, is that we perceive good governmental support in France. So this is something that for projects of this large scale and at this time, this is something that is essential. And just to finish in terms of the development, the calendar that you can see here, we started the development of this project in 2024. We are now during the 3 years of development that will include the feasibility study that is already done, pre-feed that we are finishing now, permitting, and the feed engineering. So after these 3 years estimated of development, we should be reaching a final investment decision by the end of 2026. And after that, 3 years of construction for the EPC, in fact, so that we can be in operation by the end of 2029 or beginning of 2030. And this was very quickly some explanation about 30G, about the project we are developing in France. I'd be glad to respond to any questions that may come. Thank you very much.
Thank you, Ignacio, for these fruitful insights in this fascinating project. Our third expert is Luis Viga, who, as country manager of Fortescue Future Industries in Brazil, is leading the development of large-scale hydrogen projects. Fortescue is a global frontrunner in the commodities industry and is investing heavily in renewable energy, particularly in wind and solar farms, for the production of green hydrogen and ammonia. Luis is also the president of the Brazilian Association of Green Hydrogen Industry, and he has played a key role in the formulation of the Brazilian hydrogen law. Today he gives us insights into Brazil's role in the global ammonia value chain and the partnerships that can be developed with Europe. Welcome, Luis, and this is your floor.
Hi, Charlie. Thank you so much for the invitation from the German Gas and Hydrogen Association. I also salute my colleagues Ignacio and Stefan. So I'm speaking from Brazil, so outside Europe. Maybe I can give you some new perspectives from all the exciting things that are happening in Europe. So I'm going to share my presentation with you right now. So I'm going to divide my presentation in 2 parts. I'm going to talk about the Green Hydrogen Association in Brazil first, and then I'm going to talk about the Fortescue project here in Brazil. So the ABIV mission and our goals, of course, it's dissemination, as Stefan was talking about the green hydrogen, the green ammonia industry. Leadership also to help the government to put in place the right policies and support that's needed for starting this industry. As Ignacio mentioned, the support from France, we do the same in Brazil. It's very important to have the support from government and also the private sector. Competitiveness, we look at make sure that in this case, Brazil has the lowest cost of green hydrogen and green ammonia globally, so we're competitive and it can provide a product that's to Europe or to the local market that's cheap. Sustainability, of course, and commitment to society. Very important that most of the projects in Brazil here are in locations of that need more development. They're outside the normal place, which is Rio de Janeiro and São Paulo, which are heavy industrialized and so on. And we are going to the Northeast, which there's a huge opportunity for development of the population, education, and so on. So a little bit about the companies that are part of ABIV. You are going to see all basically large companies, multinational. So we have ArcelorMittal, Yara, ThyssenKrupp, talking about Germany, very large energy providers in Brazil like Eletrobras, EDF, from France, of course, Baker Hughes, and also a lot of industry developers and associations from different states of Brazil. A little bit about the framework that we have been constructing with the government, and this is good news. Since last year, Brazil had launched the program to support green hydrogen and green ammonia. And it's kind of the same that you guys do in Europe, is trying to close the gap. So it was now commissioned and approved by law around $5 billion to support on the gap between green and gray. So this should help with, of course, like cheap energy and in fact, a lot of energy that Brazil has. Over 90% of the Brazilian grid is renewables, which is a big advantage for producing green hydrogen and green ammonia, because then you are RFNBO compliance from the grid, because you don't need additionality or hourly match, which increases the cost of production. So Brazil basically is on front on that because of this very green and renewable grid. Another hydrogen objectives and guidelines that was done by the government, showing that the government wants to also apply resources on research and dissemination, legal framework, and the new industrialization. Another thing very important in Brazil, if you look at our GDP, we are based on mostly oil and gas, agriculture, and mining, right? And if you take agriculture, like Europe, we import, even though we are one of the largest producers of food in the world, we import over 90% of our fertilizers. And we are heavily impacted by the war in Europe, right? So it's also for us to continue to have security to provide food for the world. It's important to have also fertilizers produced in Brazil. And we think that green hydrogen and green ammonia and the fertilizers from that, it's a path to have these fertilizers. Normally, our natural gas is very expensive here in Brazil. That's why we import the fertilizers. With green hydrogen here, cheap green hydrogen, we can start producing fertilizers here. The mining industry. We're talking about, we are also exporters of the raw iron material pellets. There's a big chance of us doing HBI here and exporting these. So there is what I'm trying to say, that the domestic market has a lot of synergy with the green hydrogen and green ammonia, right? Which could help a lot Brazil and also help to decarbonize the world. Little bit of the grid in Brazil. It's a big grid, all interconnected from north to south. Is 200 gigawatts of installed capacity, and it's scalable. There are a lot of lands with good potential for wind and solar. So that also is a good thing, because when you look at a project and you want to replicate several projects and then reduce the overall cost with shared infrastructures and economies of scale. So Brazil, it's a great place. We don't need to stop in 1 or 2 or 3 projects. We can grow and grow. So now I'm going to go to the Fortescue specific project. And what I want to tell you here is like to show this is probably the most advanced project in Brazil right now in the gigawatt scale, right? And I'm going to give you a little bit of flavor why we chose Brazil. Fortescue was all over the world, still with some projects all over the world, but Brazil is one of the priorities now, and there are reasons for that. So we already spoke about Fortescue. We are the fourth largest iron ore mining company in the world. I'm not going to talk more about that, but I want to show you how we are reshaping the company. Today, we are a mining company where it comes all the revenues and give us the financial capabilities for us to finance our transition. And we are now a green technology company. So we're developing a lot of green technology, green hydrogen and green ammonia usage. So we're showing the world that's possible to do it, right? And that will help also our mining, because some of this equipment, as you see, will be applied straight in our mining business, helping us to decarbonize. We are also on the side of green hydrogen and green ammonia as a producers. As I mentioned, in Brazil, we are pretty much advanced, and we want to be a large producer for the world and for Brazil as well. On the Fortescue, we have approved already by 2030. We have $6.2 billion approved to decarbonize Scope 1 and Scope 2. Not going to go into details here, but there's a path of several investments in equipment, wind and solar, all that we think that it's a great business for us to decarbonize, to differentiate our company on the mining business. A little bit of examples of our technology, right? We have our vertical operation in the Pilbara in Australia, where we are on minings, trains, ships, and we are decarbonizing. For example, this is an electric train already working in our Pilbara sites in tests with batteries. This is also a ship, our Green Pioneer, that went from Singapore to Dubai, and now in fact is in the UK. It runs in diesel and ammonia. So we're showing the world that's possible to use ammonia in this type of vessels. And this technology, we are working on that and making it better for the utilization of not only for fertilizers, but for the maritime industry as well. So this is a reality. Also electric excavators on site in Pilbara, battery electric train, electric trucks, mining trucks. This is all reality. We also acquired, and this is good, when you show our powerhouse in terms of engineering and capabilities, we acquired Williams Advanced Engineering, the large experience in Formula 1 in the batteries, right? The development. We acquired Williams Advanced Engineering to help us to manufacture and design better batteries for the industry. So talking about the PECEM project, with the Brazil project in Brazil, why we chose Brazil? Cheap energy and scalability, right? So if you look, a lot of studies in the world, they show Brazil as the lowest LCOA in the world, right? Because you have cheap wind and solar, and you have hydro as well, with over 90% renewables. So that's why we think in Brazil it's the right place after going all over the world. Also, Brazil, in terms of, it's not investment grade, but when you look at to the global south, Brazil is a very secure and stable country with laws that work well. So in terms of investment, you look at fundings, there's a lot of interest, not only from the multilaterals, ECAs, but also international banks. And there's also infrastructure, the grid, the ports. You have a picture here behind me. The ports are already there. So you don't need to build much. You need to concentrate on building your green hydrogen and green ammonia plant. Brazil has 90% plus of, this graphic shows 90% plus consistently on renewables in the entire Brazil. And in the Northeast, where the same plant is located is 90% all the time. A little bit about our project in terms of capacity is 1.2 gigawatts of capacity. It's a large, very large project, right? We think that we need scale to be competitive. With annual production of 175,000 tons of green hydrogen, that will give 900,000 tons of green ammonia and an investment around $3 to $4 billion. A little bit of the infrastructure on site that we already have, the ports. This is basically where you have our plants where it's designed to be located. So you have the green hydrogen plant, the green ammonia plant. Of course, as mentioned by Stephen, the transportation for hydrogen is ammonia now. So we are transforming everything to ammonia to export to Europe. So we are advanced. So this is a community development. So this is the actual site where we already hold more than 900, almost 900 engagements with community. So all people, because they have ammonia, so they need to be educated and so on, what's going on. So this is very important for Fortescue, include the community around our projects. We are the first ones to have the environmental license. It's already there. And this actual work on site. So you already have people on site. Although we didn't take the investment decision yet, we are doing already geotechnical and maritime studies. So almost 100 people already mobilized just on the site to start getting all this information. Also, we are partnership not only with the government, but the industry overall here. So with the support of the industry and getting all the supply chain support the project, we have better engagement from the society, from the industry, which help us to develop our project faster. Not going to go much. I think Inácio gave a great overview here in terms of production of ammonia. So, but basically we get the energy from the grid. The grid is already renewable. So this is a huge advantage. We do the electrolysis, transforming ammonia, and then ship to Europe as one of our markets. But we also have a chance to do this in Brazil as well. So our investment decision is now in 2026. We already concluded the FEED. The pre-feasibility, we are in FEED now. We are concluding the FEED by the second quarter of this year. We already have EPCs. We already selected the technology. We already have a financial advisor in place. We already have pre-contracts of energy, the lands, the water. So everything, this is a real project. One of the things that I want to make sure that our audience understand, that this is not a PowerPoint project anymore. This is reality. And hopefully, if the price is right and we are able to close the gaps, right, between gray and green, we're going to have probably the largest project in the world producing green hydrogen and green ammonia. So, as I mentioned, we are the first contract to have a lease of lands, first environmental license, early works already in place, people on site, project approved by the government. So there is extensive, extensive process for you to approve to be able to export. So that shows maturity. And also the same project of Fortescue was selected by ITA, the Industrial Transition Accelerator, from Bloomberg and the COP, and also several funding mechanisms from Brazil attesting the level of maturity. So I mentioned already that where we are on the CapEx, that we are finalizing this by the second quarter of this year, pre-contract of PPAs. We are applying for the government incentives. External off-takers, we have a team in Europe just working off-takers. And we have financial advisor in place, which is Santander, by the way, European bank, that's helping us to go through all the banks and do the funding. The good news here is that, of course, you still need to go through all the financials, but there is a huge, huge interest of banks in Brazil for multilaterals, ECAs to support this project. Thank you very much.
Thank you, Luis, for this fascinating insights into Brazil's ammonia activities. And now, ladies and gentlemen, you have the opportunity to ask questions to our speakers. Please feel free to use the chat function or the hand raising function. I have one question for you, Luis. Are there already concrete discussions or projects with the European partners to create long-term supply contracts for green ammonia or green hydrogen?
We have some MOUs signed, non-binding MOUs, right? What we are working now, first thing is you need to understand your cost, right? You need to do engineering. Everybody, you look at all these graphics, Bloomberg, McKinsey, and all these things. But reality, unless you do it, unless you do it large scale, you understand your costs. So what we are doing is collecting all our costs, collecting all our risks to be able to go to these off-takers and then discuss serious contracts in terms of cost, price, and tenure, right? So yes, there's a lot of discussion about that.
Mm-hmm. There are some two other questions for you, Luis. Why the FID only in 2026? If this is a real project, as you pointed out, can you elaborate if a firm offtake is in place?
It's the process, right? So if you're looking at a project like that, first you need to close all the engineering, right? Then you give the engineering to an EPC. And this is going to be built maybe for 3-4 EPCs on this scale, right? These contracts needs to be there needs to be an oversight from the banks and the funding mechanisms to understand the interface between the contracts and the interface risk that needs to be managed in a new industry. So it's not it's not a walk on the park that was done multiple times before. They need to understand all the risks that you have in the supply chain. So you go have the EPCs by June, the CapEx by June, then you have all EPC contractors giving us proposals by December. Then you have the banks needs to go and do their own due diligence, right? That takes probably 6-9 months. And then you have an FID. So the process is long. So if you want to have, if you really want to have not only the financials right, but understand that if the banks are okay with the risks that you have in a project like this size.
And can you say something about the expected price in euro per kilogram or US dollar per kilogram produced? And what is the expected costs if this green ammonia landed in Europe?
So I can say that's very competitive, right? But I cannot open the price for you. That's what we do with the off-takers. I hope that you understand.
Yeah.
But it's very competitive. Why is competitive? Because the green energy is cheap. If you look at Brazil, you may look at something between $20 to $30, $35, like the green energy. And you don't need additionality and so on. So when you look at Europe, the prices are higher, right? So, of course, we have also this advantage against Europe because we need to transport this to Europe, right? But when you look at the energy and so on, Brazil is a great place to do it. Off-takers, I think that it's not going to be the same price of gray ammonia. We all know that, right? What we do have is some reference from price that from the auctions that happen in Europe, right? We had in Morocco, if I'm not mistaken, right? That's exporting from one of the funding mechanisms from Europe. That will give you a little bit of idea.
Mm-hmm. And then I have a technical question for Ignacio. Are you releasing the same amount of carbon dioxide from dolomite when you synthesize CAN that you have saved through electrolysis? Shouldn't you try to avoid dolomite as a fertilizer carrier substance? I'm no chemical engineer, so I don't understand everything about it, but I'm sure you...
No, but we can explain something. Yeah, to produce CAN, you need, I mean, there are two types of material you can use. You can use dolomite or you can use limestone. And one of the reasons why we have selected the dolomite is because its CO2 footprint is much lower than the one of limestone, because it's a mineral that you have to take from a quarry, but there is no calcination process in the production. So the CO2 footprint of dolomite is really low. It is around 0.1 tons of CO2 per ton of product, which is really low. I mean, the traditional gray fertilizers, they are a CO2 footprint of between 1 and 2 tons of CO2 per ton of product. So we are 100 times lower than that. it's not comparable. I mean, we read the CO2 footprint that we remove with the one that the dolomite will provide.
Okay. Another question for Stephen. Europe is betting big on hydrogen, but ammonia as an energy source has so far received less attention. What policy and regulatory measures would be needed to establish ammonia more firmly as part of Europe's energy infrastructure?
Yes, thank you very much. That's a good question. Well, that's really part of our raison d'être as an association. As I mentioned in the very beginning, a lot has been said and activities carried out on the hydrogen front. And up until now, ammonia is really very much seen as a hydrogen derivative, and that's what needs to change. And that's why we have set up this association. I think what would be very important is, well, whether it be ammonia or hydrogen for that matter, what we advocate for is technology neutrality. We need to be able to use the different production pathways for ammonia and hydrogen in Europe, hence bringing down the costs of production. Notably, in the Clean Industrial Deal, the Commission has acknowledged that issue, and there will be the publication of the Low Carbon Hydrogen Delegated Act very soon, as well as the first step is going to be initiated to review the infamous Rufinobio Delegated Act. So that is going to be kickstarted very soon. So that's on the production side. Then on the demand side, which is one of the issues in Europe. I mean, I think when it comes to ammonia and fertilizer specifically, at least there we know where the demand is because we have an existing value chain. But when we're talking about new end uses, that's where we as an association are going to be pushing for actual mandates to use ammonia as a fuel in the maritime sector, in line with Fuel EU Maritime, but also IMO activities, which are carrying on in parallel. As well as mandates also for use of ammonia as, well, basically a chemical battery. So renewable storage in Europe. And then, as I mentioned in my presentation, looking at ammonia for power production. I think there EU-wide mandates may be a little trickier because it really depends on the energy mix in any given member state. So I think that will be more on a case-by-case basis.
Okay, thank you. There is another question for Luis, once again about the costs. Can you say something about the industrial price index for electrical power in Brazil?
It's anything between, let's say, $25 to $35 megawatt hour.
Okay. And another question that I think you would like. If a company is interested in the green ammonia from Fortescue project, who would be the best person to talk to?
I would love to talk with you, and I can direct you to our teams that are on the commercialization teams.
Okay.
That's what we need, right? Like the question is good. Like about this market is it's difficult to get the right price that's right for the producer and for the consumer. Right? So you need to do all your engineering on that. And the second thing is that the tenure, right? To finance a big project like that, you need tenure of 10, 15 years, which is also a challenge in the industry. So everything is new, right? And what we want is to partnership with our possible off-takers to find a solution that it's good for both.
Another question for Ignacio. The fertilizer industry is extremely price sensitive. What is needed to encourage farmers to switch to green fertilizers?
Yeah, everything related with prices is always very sensitive, but what we have seen is that there are clients and there are off-takers, and having Heineken as one of our shareholders is the best example. Off-takers that have are capable of paying the premium associated to these fertilizers and that are willing to do it. Farmers that belong to cooperatives, and these cooperatives are in contact with final food and beverage companies. This is the way in which farmers should be interested in having access to these fertilizers. No, being involved in the distribution and in the value chain that will take them to the type of final users, to the type of food and beverage companies like are interested in paying this premium. No. So many farmers that, as I said, that belong to cooperatives, and these cooperatives, many of them, in vivo is one of them, but there are many others that are interested in commercializing this type of fertilizers and this type of crops produced with these fertilizers because there are food and beverage companies that are willing to pay them. So there is market for it. It has difficulties, of course, many things that have to be worked on. But the market is there and the farmers should be on it.
Mm-hmm. Thank you. And another question for Stephen. Do you see realistic chances for a European pipeline or terminal network for ammonia similar to those discussed for hydrogen?
They flip that question the other way around. One of the major differences is that the infrastructure for ammonia is actually already in place in Europe. We have 30 terminals, 30 plus terminals already in operation in Europe. I mean, ammonia has been traded for the past 100 years. Nowadays, about between 18 and 20 million tons of ammonia are shipped worldwide and go through those terminals. So actually, that's one of the advantages of direct use of ammonia versus hydrogen, is that you already have an infrastructure in place and we know how to handle the molecule. Then when it comes to dedicated pipelines in Europe, well, for the moment, what we're looking at is the European hydrogen backbone, which is essentially a hydrogen network. We cannot exclude that further down the line there may be ammonia dedicated pipeline, but I think that would be very specific, depending on very specific demand centers in Europe. Notably around the Ruhrgebiet, but that remains still to be seen. So most likely what will happen is that the ammonia that is imported will go via our terminals in operation in Europe, and then depending on the end use can either be transported by rail or by barges in the form of ammonia and then directly used as ammonia. Or what we are seeing increasingly is cracking ammonia in the major harbors and ports in Europe, and then feeding that hydrogen to the end users further down the line. So really much depends on the end use.
Mm-hmm. There is another question about the end use. NH3 usage as a fuel means burning engine, right? What about the N2O and NOx emissions in the exhaust gases? Are there needs to install a complete catalytic reduction technology versus oxy-fuel burning?
Yes, so you do need to install that. There's still quite a bit of research ongoing on that. And a number of engines are being tested in Europe, but also in Asia, with the first commercial ships coming online as early as 2026. And all those technologies do include, yes, NOx and SOx emission reduction technologies. Also, but maybe less for the moment prominent is also the use of ammonia in fuel cells, but there the TRLs are still quite low.
Mm-hmm. And then I have another question for Luis. I don't know if you can answer it because it's more in the direction of Fortescue as a mining company. What is your opinion on white hydrogen in comparison to green or low carbon hydrogen?
So we love green hydrogen, right? So that's where we're going as a company. We think that it's the industry that are going to have less emission of CO2. So that's a straightforward question answer to us.
Okay.
Although the price today is higher, we think that with the adoption and the increase of technology investment and scale productivity, we are going to have on the places that have a great energy, great resource, it's going to be comparable in the future with the gray ammonia or the gray hydrogen. So we're investing this in what we believe that's the most competitive place right now. But what we are looking at is we don't need a premium, right? Like we hope that the industry is going to develop to become like in par.
Okay, so our very interesting comes near to an end. I have a last question for all of you three. If we look ahead to 2035, what role do you think ammonia will realistically play then as a fuel, as a raw material, or a commodity, or anything else? Stephen, maybe you will start.
I think a lot has been said today. I think we'll be looking at the decarbonization of the conventional value chains of ammonia, using the existing infrastructure, as I mentioned. And then I hope we will have made significant advancements on creating the new value chains, and that is on maritime and use as energy and storage. Just to give you an idea, sort of, I mean, it's not 2035, but it's actually 2050. I mean, the size of the ammonia market today is a little under 200 million tons per year. Looking at different reports, we're looking at over 600 million tons of ammonia by 2050. And 33% of that is for the maritime sector alone. So this is why we are investing a lot of time and most of our activities in developing the maritime value chain for ammonia.
Mm-hmm. Thank you. So, Ignacio, how do you think will be the role of ammonia in 2035?
I could say that by 2035, not only ammonia, but also in general, green hydrogen, the sectors in which will be more in use will be the hard-to-abate sectors in which hydrogen and ammonia are already being used. No, this is what I see that should be the first sectors in which ammonia will be implemented, and that's why we see that fertilizers is maybe the first sector in which by 2035 the replacement of gray ammonia with green ammonia can be a reality at larger scale by that time, you know? And maybe sometime later after 2035 will be the time where other sectors like maritime or others can start taking more use of green ammonia. This is, I would say.
Mm-hmm. And last but not least, Luis, what is your vision for 2035 and ammonia?
Okay, now I hope that we have already ammonia from a very competitive price of ammonia, so we don't need to differentiate green and gray on the premiums. We may still need to have some, but we have an industry that with projects that are becoming more and more viable in feasibility and getting to FID decisions, right? So that's the view. And then you have the maritime, as Stephen mentioned, that Ignacio mentioned also, so you can start to replace gray with green. Right, and that's the view. That's what we are working every day here. We try to guarantee the cheapest one that you can get at this moment, and then in the future even get cheaper.
Okay, thank you very much. Thank you, Stephen. Thank you, Ignacio. Thank you, Luis, for this very interesting hour about ammonia. Vielen Dank auch an Sie, liebe Zuschauerinnen und Zuschauer, für Ihr Interesse und Ihre Fragen. Die Präsentationen werden wir Ihnen im Nachgang zu dieser Veranstaltung zusenden und die Aufzeichnungen finden Sie zeitnah auf unserem YouTube-Kanal. Wir werden das Thema Ammoniak weiter begleiten. In Kürze wollen wir in einer weiteren Veranstaltung einen Blick werfen, nachdem wir uns heute die internationale und die europäische Perspektive angeschaut haben, dann auf die nationalen Aktivitäten. Bis dahin wünschen wir Ihnen eine erfolgreiche Zeit und bleiben Sie gesund. Bis zum nächsten Mal.